So in the last segment, we looked at what it means to be a factor. All right, factors are the dimensions of the rectangles that we can make with that number of chips. So if a factor divides n without leaving a remainder, then let's look at the word multiple. All right, and let's define a multiple of n then is any number that n divides. And that probably sounds unfamiliar to you, right? A multiple is any number that n divides. All right, if I asked you what is a multiple, you'd probably have a hard time giving me this definition, but I bet you could list multiples, right? So if I said to you, what are the multiples of 8? You'd say 8, 16, 24, 32, 40, 48. You'd count by 8s, right? So multiples are of any number n are n, 2n, 3n, 4n, 5n, and on and on and on forever. The number of factors that we have for any given number would be finite, all right? But every number has an infinite number of multiples. So notice that n would divide any of these. Now we're using the word divide, all right? All of you think you know what divides means, right? But if I said, give me a really good definition of divides, I would imagine you might struggle with that. And that's one of those situations where sometimes we use words all the time, and yet we don't really know how to define them. So we're going to define the word divides in a minute, but an example I give to illustrate the way that we can use words even if we can't define them. I remember when my son was about 8, and he asked me what the word ironic meant. All right, and I use the word ironic all the time. I know what, when to say, oh, that's ironic. And yet trying to explain that and actually define the word ironic, I couldn't do it, and so my son says to me, oh, so it means like funny? And I said, well, not exactly funny. And then I even said to my son, it's ironic that I can't tell you what ironic means. All right, but anyway, it's the same idea here. You guys know what divides means, or at least you think you do. But if I asked you for a good definition of divides, I bet you couldn't give me one. But anyway, I am going to introduce you to a new symbol for a college level symbol for saying that one number divides another number. So the symbol that we're going to use, and this means A divides B. All right, this is used a lot in upper level math, but I use it on your homework and things like that too in this section. Oh, A divides B, and then put my quotation marks, okay? So the meaning of that is A divides B, and in symbols it looks like this. A with a slash and then a B. Okay, so again, you have an intuitive sense of what divides mean. So if I said to you true or false, right, and this says 5 divides 30, and this says 5 divides 31. Okay, so if I said to you, well, which is true and which is false? All right, you understand this concept of divides, and so you would label this as true, right? And then you'd say, well, no, that's false. 5 does not divide 31. And then my question is, well, why is it false? Because I can take out my calculator. I can type 31 divided by 5, and I can get an answer of 6.25. So it's not like I can't divide it. But what's the difference maker? What's making me say that this divides and this doesn't? And again, I wish we were in class because then we could have a discussion and someone could point out that over here, I have to multiply 5 by a decimal to get 31. Whereas over here, I multiply 5 by a whole number to get 30. All right, so that's going to get me to a college level definition of divides, where we are going to say this. Let me switch to text box since it's easier. And I'm going to say A divides B. if there exists some whole number, so that's the key, whole number C, such that A times C equals B. Okay, so that's a college level definition. Okay, so in this problem, this would be my A, right? I was able to find a C that is a whole number to equal B. Here, I was not able to find a C that was a whole number, and therefore it does not divide. So let me just give you some notes on prime and composite numbers. Although I'm sure that you all have a pretty good sense of what those numbers are. All right, so let's say this about primes. Has exactly two factors, one and itself. Based on this definition, one is not prime and neither is 0. Okay, because the number 1 does not have two factors, it only has one factor. All right, and then composite. So sometimes when we talk about prime and composite, and it's kind of understood that when we're doing this, we are in the whole number system. All right, when we are talking about primes and composites, we're not talking about the negative integers that we just studied. We're not talking about fractions and decimals. Okay, it's understood we're talking about whole numbers. All right, so composite numbers I'm going to say this: a number is composite if there exists a number P. This is going to be a college level definition, okay? Because you might say, well, it's composite then if it has a factor other than one in itself, all right? But let me give you a college level definition of composite. A number is composite if there exists a number P where P has to lie between 1 and n, and P divides n. So one of the things that we're going to look at is we're going to find the collection of all of the prime numbers between 0 and 100. So we'll do that on the next segment. All right, and then the next thing we have to start looking at, and we're going to use information that we learned in the first video, is I'm going to give you numbers like big numbers, like this, and say, well, is this prime or composite? Right, and we're going to have to figure out, do these numbers have divisors other than 1 in itself? And how do we do that efficiently? Right, I mean, do I need to get my calculator out and literally type in and try dividing this by every single number, starting with 2 and moving on to 586, right, to see if anything divides it? So I want you to be trying to think about, kind of mull that around in your brain, how we can use what we learned about factors back at the beginning of the segment, right? There are some things we learned about factors that would let me cut my work in half. And you might know some divisibility rules, all right? So that's something else we need to talk about, right? You could say, well, I know 2 can't go in, right? Well, as soon as you know 2 can't go in, you know, what else do you know that you could eliminate, right? So if I were going to look at the list of all of the numbers, 2, 3, 4, 5, 6, 7, 8, do I need to sit here with my calculator and test every single one of these numbers or not, right? All the way up to 586. All right, so I want you to try to think about this because again, if we were in class, you'd be talking in groups and we'd be brainstorming and right now you would be having a discussion with the people in your groups about it. And unfortunately, we miss out on that. But try to think about it on your own. All right, don't just wait for me to tell you all the answers, but try to really problem solve and try to put together some of the pieces that we just discussed.